Hello, geometry students. Here's your lesson for section 1-1, Understanding Points, Lines, and Planes. Missy McCarthy, Okemos High School math instructor. We'll begin each lesson with a list of statements called I can statements, which is just a list of learning targets or learning objectives for each lesson. So by the end of this video, you should be able to identify and draw and name points, lines, and planes. Identify when objects are collinear, non-collinear, coplanar, or non-coplanar. Identify, draw, and name segments, endpoints, rays, and opposite rays. Define the term postulate. Identify the intersection of geometric objects. And make sense of the 5 postulates regarding points, lines, and planes and their intersections. So be paying attention to these as we go through each part of the lesson. Before we get started with that particulars of the lesson, we're going to talk a little bit in general about the word geometry and what it is. Geometry is actually defined using 2 words. Geo, or 2 parts of a word, maybe I should say, is the first part, and it just means earth. And then the metry part also could come from the word metric, which means measure. So geometry, as depicted in our image here, actually just means to measure the earth. Now there was a system of geometry developed by a Greek mathematician named Euclid in about 300 BC. And when he developed the system for geometry, he actually broke it down into the most basic fundamentals of the system and then built it from there. In his system, he actually had some terms, which we're going to call undefined terms, because they're terms that we can't define in terms of other objects in geometry. They're the most basic building blocks of geometry. Those 3 undefined terms are points, lines, and planes. And what we're going to do is use our system or build our system of geometry based on these fundamental terms: a point, a line, and a plane. So what are these undefined terms? What's a point, what's a line, and what's a plane? So here are the definitions of these terms. A point just names a location. So if you were trying to identify a particular object, or let's say you had a cube, and you want to identify a particular location on that cube, you might identify it by saying, look at that point, point A. Okay, so a point is usually represented with a dot. It's usually named with a capital letter, and when we draw a diagram of it, we put the dot in the capital letter, so that would be point A. Now there's also a line here. Say we had a line, and our line has 2 points on it. Let's say our line has points A and B on it, or an infinite number of points. Actually, we could put points all along there if we wanted. And a line is just a straight path that has no thickness and extends forever in each direction. That's why we put those arrows on the ends to indicate that it extends forever. Lines are usually named with 2 capital letters, so we would draw something like this, and I would say that was line AB, or I could also call it line BA. Or I could use a script lowercase letter like an M and say that that is line M. So there's a way to draw a line here. This is the way to name a line, and there's the definition of a line. Our last undefined term is a plane, and it's just a flat surface that has no thickness and extends forever. So if you can imagine a piece of paper that actually doesn't end on the edges, it just extends forever, floating in space, that would be considered a plane. We usually name our planes with a script letter. You can see the script letter R here, so it will be plane R. Or we name our planes with 3 points on the plane. So A, B, and C are all points in this plane. And then we would use an image like this to draw a plane. I do want to call your attention to the bottom of the screen here. Every time we're talking about one of your learning targets, you will see the I can statement for that learning target at the bottom of the screen. So that's just something to pay attention to as you're going through your video lessons. Okay, so when we talk about these points, lines, and planes, we can talk about these objects either being collinear or coplanar. So what on earth does that mean? Well, collinear, this is actually just a compound word. Co, like co-workers, means together. And linear just means a line. So if I have a line and it has 2 points on it or more, I can say these points A and B are collinear because they are on the line together. I can also add a third point and say A, B, and C are collinear because they are on the line together. Now, if we had A here, B here, and C here, these would be what we call non-collinear because they are not on a line together. Okay? Same with coplanar and a plane together. So if I had a plane and I had A, B, and C, now points A, B, and C are coplanar. And we'll talk about non-coplanar a little bit later. Okay, so let's look at this diagram here. Are we able to name a point? I can name several points. I can name point A. Oops. I can name point A, B, C, E, and D. Those are all points in this diagram. Can we name 2 lines? We absolutely can. Remember, we name lines by having this type of a symbol, and I would say we've got line AB. I could also name it line AB. I could also name it line J with the lowercase script letter. And another line I'm going to name with the lowercase script letter. It could be line AC, but I'm going to name it line M, just to demonstrate that there's other ways to name lines. Could we name a plane? Absolutely, and there's 2 ways we can name a plane here. I could name plane Z with the script letter Z, or I can name it with 3 non-collinear points. I could name plane A, B, C. 3 points that don't lie on a line together. Are points E and point C collinear? Remember, collinear is one of our vocabulary words. It means on a line together. So I'm looking at points E and C, and I actually could draw a line through them. So I'm going to say yes, E and C are collinear because they are on a line together. Now we have a few other terms here that we're going to define, and those terms are segment, endpoint, ray, and opposite ray. Again, here we have the definition. A segment is a line segment is just part of a line consisting of 2 points and all the points in between. So if you look at this diagram here, we have a diagram of a segment, which is all the points in between, including these endpoints. So that would be line segment AB or line segment BA. There's 2 ways you can name it. Now, an endpoint is just the point at the end of a segment or the starting point of a ray. So the endpoints here would be A and B. The endpoints here would be C and D. And we name the endpoints just like we name any other points. A ray is also a part of a line, but it starts at an endpoint and extends forever in one direction. So if we were to start here at point R and extend forever in the direction of S, that would be ray RS. Notice you could also draw it in this direction, starting with R and extending forever in that direction. This is not ray SR. We always name rays starting with the endpoint first. And then opposite rays are just 2 rays that have a common endpoint and form a line. So one ray here is ray EG, another ray is ray EF, and they both have a common endpoint, which is E, and they come together to form a line. So that makes EF and EG opposite rays. Other building blocks of geometry is something called a postulate or an axiom. And a postulate or an axiom is just a statement that is accepted as true without proof. A statement accepted as true without proof. And there are certain axioms or postulates that we're going to have in geometry, things that we have to just accept as true, and then we can prove that other things are true based on the fact that these axioms or postulates are true. So our first three axioms or postulates that we're going to have is the fact that through any 2 points there is exactly one line. This isn't something we can necessarily prove, it's just accepted as true, but no matter where you draw 2 points, if I were to draw 2 points, draw a point here and a point here, there is only one line that can go through those 2 points. Okay, so we're accepting that as true. The second one is that through any non-collinear points, there is exactly one plane containing them. So no matter where you have 3 points that are not on the same line together, let's call them A, B, and C, there's exactly one plane that contains those 3 points. Now the way that I think about it is by drawing a triangle with those 3 points as the endpoints or the vertices of the triangle, and then think about the flat surface that contains that triangle. There is only one unique flat surface that will contain that triangle. And then lastly, if 2 points lie in a plane, then the line containing those points also lies in a plane. So if you had 2 points here, C and D, that lie in a plane, then the line containing C and D also lie in that same plane. Again, 3 statements that we just accept as true without proof. An intersection is a set of all the points in 2 or more figures have in common. The next 2 postulates that we're going to study describe intersections. So if we think about 2 lines intersecting, they intersect according to this postulate in exactly 1 point. Now I would challenge you to try to draw 2 lines that don't intersect in exactly 1 point. If I draw a line here, if they intersect, it says, and they're not parallel lines, and draw a line here, they're going to intersect in 1 point and 1 point only. That's the only point that they have in common. Likewise, for this postulate, if I have 2 planes that intersect, they intersect in exactly 1 line. So let's say that I have this plane here, and then I have another plane that it intersects, kind of going like that. Then those planes intersect in a line where these points are actually on that line. Okay, so any 2 planes that intersect in exactly 1 line. That's another illustration for that second postulate. And that's, again, if the planes intersect at all. They don't have to intersect, but if they do, it's going to intersect in a line. All right, so we're going to sketch the following. So the first one is we're going to sketch a line that intersects a plane but does not lie in the plane. So let me imagine what that would look like here. Let's say I have a plane, and I don't want the line to lie in the plane. I just want it to touch the plane or intersect the plane, but doesn't lie in it. So I'm imagining my line is kind of like piercing, like a sheet. If my plane was a sheet of paper, and this line is going through the paper, and it's only touching it at 1 point, point A, but the line does not lie in the plane. And then 2 planes that intersect in exactly 1 line. I actually drew that already, but I'll try to draw another illustration. Let's have 1 plane there, and the other plane here, and then those planes intersect right here on that line. Okay, lastly, we're going to sketch a figure that shows 2 lines intersect in 1 point in a plane, but only one of the lines lies in the plane. Let's try this one. So we've got 2 lines intersecting at 1 point in the plane, but only one of them lies in the plane. So here's my plane. Here's my line that lies in the plane. And then I want another line that intersects at a point right here. That dotted line just means it's beneath the plane there. Okay, so they intersect, say, at point B. One line lies in the plane and the other line does not. So we'll wrap up each lesson with the I can statements. You want to, again, make sure that you understand these statements and that you felt sufficiently, that you felt good about the statements and that you are able to follow along with each of these kinds of statements and do the things that it lists here. Again, in class the next day, we will make sure that we revisit the I can statements and we will practice many of the things that we gave examples for in the video. Lastly, before you come into class tomorrow, I want you to write down at least one question that you have about today's lesson and bring it in tomorrow, and we'll do our very best to answer it. Okay, that's the end of lesson 1. See you in class.